Hello student, this is Latif sir. Today I'll discuss about ISC class 12 chemistry, the second chapter, solution. Okay, today I'll discuss about concentration of solution. We know that there are various way by which you can represent the concentration of a solution. Let's see this representation of concentration of solution in using various method. Okay, first percentage by weight or W by W percentage. What is it? It is defined as the amount of solute present in 100 gram of solution. Okay, the amount of solute present in 100 gram of solution is the percentage by weight or weight percentage of solution, concentration of solution. Okay, so percentage by weight is W by W percentage is equal to weight of solute divided by weight of solution into 100. What is the formula of percentage by weight? The formula is weight of solute divided by weight of solution into 100. Second method is percentage by volume or W by V percentage or volume percentage, you can also say. It is defined as the weight of solute present in 100 ml. Here the here the you have to use the volume of solution. In case of weight percentage, I have written here, in case of weight percentage, the amount of solute present in 100 gram, that is mass of solution here. But in case of volume percentage, you have to use the volume of solution. Okay, so percentage by volume, it is defined as the weight of solute present in 100 ml of solution. So percentage by volume is equal to weight of solute divided by volume of solution into 100. Weight of solute divided by volume of solution into 100. Now, now third method of representation of concentration is mole fraction. Mole fraction. Hmm. So it is defined as the number of moles of a compound to the total number of moles of all compounds in the solution. Okay, that is mole fraction is equal to number of moles of that particular component divided by the total number of moles present in the solution of all components. Okay, so for example, for a binary solution, if the number of moles of A and B are Na and Nb respectively, the mole fraction of A will be Xa. Mole fraction is represented by X. So Xa is equal to Na by Na plus Nb. And similarly, mole fraction of B will be Xb is equal to Nb by Na plus Nb. So, and you have to remember total mole fraction of all components will be always equal to 1. So Xa plus Xb is equal to 1. Fourth, parts per million or ppm. It is defined as the part of component per million parts, that is 10 to the power 6, that is 10 to the power 6 of the solution. It is defined as the parts of a components per million parts of the solution. It is widely used when the solute is present in very trace quantity. Okay, very trace quantity. If the solid present in very trace quantity in a solution, then you have to use this method of representation of concentration, that is ppm. Ppm means number of parts of the component divided by total number of parts of all the components into 10 to the 6, means 10 lakh. 10 to the 6 means 10 lakh. Okay, or 1 million. Now, important concentration method of representation of concentration is molarity, and you have to read molality, normality. These are important at this level. Okay, so molarity. What is molarity? Represented by capital M. It is the number of moles of solute present in 1 liter, that is 1 decimeter cube or 1000 cc or 1000 ml of the solution. It is defined. It is the number of moles of solute present in 1 liter of the solution. So molarity molarity is equal to number of moles of solute divided by number volume of the solution in liter, or you can also represent in 1000 ml. Okay, so molarity, some point molarity varies with temperature due to the change in volume of the solution. When molarity of a solution is 1 molar, it is called a molar solution. If the concentration of solution is zero point 0.1 molar, then the solution is called decimolar solution. If the concentration is zero point 0.5 molar, it is known as semi-molar solution. And molarity depends on temperature, you have to remember. If a solution having volume V1 and molarity N1, M1, capital M1, after dilution, volume becomes V2 and molarity become M2, then according to law of dilution, you can write M1 V1 is equal to M2 V2, where V1 is the initial volume and M1 is the initial concentration, and V2 is the volume after dilution, M2 is the molarity after dilution. Okay, now this is molarity, and now another concentration is method of concentration is molality, small m, and the first one is molarity, and this one is molality. It is defined as the number of moles of solute per kilogram. You have to remember per kilogram, but in molarity it is number of moles of solute per liter. Okay, so this main difference between molarity and molality. It is molality, it is the number of moles of solute per kilogram of solvent. So molality, small m, is equal to mass of solute in gram into 1000 divided by molecular weight of solute into mass of solvent in kg in gram. Hmm. Here also you can see one formula of, in case of molarity, the molarity is equal to mass of solute in gram into 1000 divided by molecular weight of solute into volume of the solution in ml. Okay, another form of molarity. By using this formula, you can calculate as a concentration of a solution in molarity. Similar formula in case of molality. Now, next concentration, uh, next type of concentration is normality. This is another method or another way of representing as a concentration of a solution. Normality, it is the number of gram equivalent of solute present in 1 liter of solution. Normality means number of gram equivalent, but in case of molarity, number of moles, you have to remember. Huh? In normality, number of gram equivalents of solute present in 1 liter of solution. So normality is the number of gram equivalent of solute, divided by volume of solution in liter. Another is formality. It is the number of formula weight of solute present per liter of the solution. Formality, it is the number of formula weights of solute present per liter of the solution. So formality is equal to mole of moles of substance added to the solution divided by volume of solution in liter. Okay. Now, important important law of this chapter of solution, Raoult's law. We know that every volatile liquids have a vapor density, because volatile means volatile substances are those substances which can easily pass to its vapor density, vapor state from its liquid state. Okay, so volatile liquid also can also be defined as the liquids which can easily pass into vapor state from their liquid state. Okay, as they can pass into and they can pass easily to the vapor state, they have some vapor pressure. Volatile liquid also have some vapor pressure. Okay, you have to remember this one, and vapor pressure is represented by P. Okay, so Raoult's law deals with the solution of volatile liquids. Now, if a binary solution have two liquids made up of two liquids, and both are volatile, one is more volatile and another is less volatile, then here you can see in the beaker two liquids are mixed. Okay, A and B, and both are volatile liquids. That is, both liquid can pass into can pass into or can go into the vapor state and can show vapor pressure. Both liquid. Okay, from they can easily pass from liquid state to vapor state. One is more volatile. That is, one liquid more can more easily pass into vapor state, and another is less easily. Okay, so, but both have some vapor pressure, and this their vapor pressure is represented by their partial pressure. Okay, so now what is Raoult's law? Raoult's law state for a solution of two volatile liquids. For a solution of two volatile liquid, the vapor pressure of each liquid, the vapor pressure of each liquid in the in the solution is less than that is less than the respective vapor pressure of pure liquids, and the equilibrium partial vapor pressure of the liquid is directly proportional to its mole fraction. The actual statement of Raoult's law is the equilibrium partial vapor pressure of the liquid is directly proportional to mole fraction. That is, partial pressure P is directly proportional to its mole fraction X. If you take only one volatile liquid, then the total pressure of the liquid is equal to its partial pressure and is vapor pressure equal. But if you made a binary solution by taking two liquids, then you will see that their partial pressure and total pressure will not be equal. And in binary solution, you can apply Raoult's law, huh, and you can calculate their partial pressure by using Raoult's law of different components of a binary solution. Here, A and B, uh, two liquids which after mixing produce a binary solution. So, partial vapor pressure of liquid A is, according to Raoult's law, partial vapor pressure is proportional to its mole fraction. If partial vapor pressure of A is Pa and its mole fraction is Xa, then Pa directly proportional to Xa according to Raoult's law. Then you have to uh, substitute or replace the proportionality sign by equal sign. So Pa is equal to some constant K into Xa. So the Raoult's law is Pa proportional to directly proportional to Xa. Then, or Pa is equal to K into Xa, where K is a constant and Xa is the mole fraction of A. And how to calculate mole fraction of A? Xa is equal to number of mole of A, Na, divided by total number of mole in the binary solution. So Na by Na plus Nb, mole fraction of A, liquid A. Now the proportionality constant K is obtained by considering the pure liquid. If you take the liquid A only, then you can also apply the Raoult's law. Then in case of pure liquid, then the mole fraction Xa will be equal to 1, because no the component B is not present there. That's why total vapor pressure is only the due to the vapor pressure of A, and mole fraction of Xa is equal to 1, because there is B is not present in this in case of pure A. Okay, so when if you take only pure A liquid, then partial pressure Pa of the liquid will be represented as Pa0. That is pure state, partial pressure in the pure state. And if you take only pure A, then mole fraction of A is equal to 1. Then then uh, substitute Xa by 1 and write Pa instead Pa0 instead of Pa. Okay, so K will be equal to Pa0, because Xa value of Xa is 1 and K is equal to Pa0. Pa0 is the partial pressure of A in pure state. Okay, so Pa is equal to Pa0 xa, because pa0 is the value of k, constant, value of the constant. This is for component A. Similarly, for liquid B, according to Gauss law, you can write partial pressure of B, that is Pb, directly proportional to its vapor pressure, its mole fraction in the liquid, Xb, that is Pb directly proportional to Xb, then Pb is equal to some constant into Xb. Huh. Now for pure B, you can write Xb is equal to 1, because no if you take only pure B liquid, then A liquid is not present, then mole fraction of Xa is equal to 0, but mole fraction of Xb is equal to 1. You have to always remember total mole fraction will be always equal to 1. If A not present, then the mole fraction of B is equal to 1. Okay, so and if you take all pure B, then the partial pressure of B will be represented as Pb0. Okay, so in case of pure B, Xb is equal to 1, then Pb0 is equal to K. Okay, that's why according to Raoult's law, Pb is equal to Pb0 into Xb. Okay, where Pb is the partial pressure of B in liquid, in solution, in solution, in binary solution, but Pb0 is the partial pressure of B in pure state. Okay, and Xb is the partial mole fraction of B in the solution. So the total vapor pressure of the solution will be equal to the sum of partial pressure of A and B. Now P is equal to Pa plus Pb. P is the total pressure, and according to Raoult's law, Pa is equal to Pa0 into Xa, and Pb is equal to Pb0 Xb. Now we know that Xa plus Xb is equal to 1. Then you can also write Xa is equal to 1 minus Xb. That's why in the next line you can see P is equal to Pa0 into 1 minus Xb, because Xa plus Xb is equal to 1, then Xa is equal to 1 minus Xb plus Pb0 Xb. So P is equal to total pressure is equal to Pa0, partial pressure of A in pure state, plus Pb0, partial pressure of B in pure state, minus Pa0, partial pressure of A in pure state, into Xb, mole fraction of B in solution. This is the Raoult's law and mathematical form of Raoult's law. Okay, important law, you have to remember the law. Thank you.